Today I'll be going over the Chapter 5 review for pre-calc, where we will be going over trig identities, proving them, and also solving trig equations. Alright, so for number one, what I'm going to do is I'm going to go walk through part A and then pause so you can try the B, C, and D on your own, and then unpause and provide the answers for those. Alright, so for part A, it wants us to write these in terms of sine and cosine only. So one thing that's really easy to do is to convert everything here into sines and cosines using our trig identities. So cotangent will turn into cosine of theta divided by sine of theta, right? And then secant we can turn into 1 divided by cosine of theta, right? And then one thing we should make sure we do is to simplify this, right? So easiest way to do that is to just cancel out the cosines. Cosines go away, and we'll be left with 1 divided by sine of theta. Right? So if you would like to pause the video here and try parts B, C, and D on your own, go ahead. Alright, so the answers for B, C, and D are shown here. If you have questions, please let us know. But moving on to number 2, 3, and 4. So how I'm going to do 2, 3, and 4 is I'm going to do number 2 fully, and then 3 and 4 I'll provide the first step so that people can try and simplify on their own from there. Right, so on these problems, what we're doing is trying to do verify identities. What that means is we're going to take the left side of the equation and try to get it to match the right side. Alright, so we should turn this whole left side into just sine squared. So one thing we can notice is that there's a tangent squared in both terms on the left side, which means we can factor it out. Alright, so we can take the tangent squared out. It'll become this 1 minus sine squared of x. Right, this still equals the sine squared of x on the right. We're not touching the right side. So what we can do here now is we can change tangent into sine divided by cosine. So sine squared divided by cosine squared. Right? And then 1 minus sine squared is one of our identities, which turns into cosine squared. It's one of those Pythagorean identities that we have. And this all still equals the sine squared. Right? If you notice now, we have a divided by sine and divided by cosine and a times cosine. So those two will simply cancel out, leaving us with sine squared of x equals sine squared of x. Right? If you think of these problems kind of like a puzzle, it gives you your end goal on the right side and it gives you your starting point. So it's kind of like follow the algebra rules till it gets to where you need it to be. If you try something, it doesn't do anything for you, it doesn't work, go back, try something else. But number 3 and 4, I will write the first step, or describe the first step to you, and you can pause the video and finish from there. So for question 3, first thing I would recommend doing is taking this tangent and cotangent, turning them into sines and cosines. So that will look like this. Tangent is sine divided by cosine. And cotangent is cosine divided by sine. And this is all divided by cosines. My suggestion is if you see a sine or a cosine, do not change it until you have to. There's nothing else to do. But if you notice this, you should notice something fairly obvious in the numerator to help you continue with the next step. You know you're done with the problem once the left side is also a secant of x. For question 4, the first step I would suggest going with is, if you notice on the right side we only want cosine squareds. On the left side we have cosine squared and sine squared. So we want to take that sine squared and turn it into 1 minus cosine squared. That's one of our Pythagorean identities. So then we'll still have cosine squared minus all this will equal 2 cosine squared of x minus 1. And again, you know you're done with this once the left side matches the right side. But I'm going to move on to the back side, so problem number 5, where we start solving some of these trig equations. Right? I'll do all of these ones because they are all different. When we're asked to solve an equation like this, our end goal is to have it be a trig function of x equals a number, and that will help us out. But yeah, so we want to get the trig function by itself, so we're going to add 1 to both sides here, add 1, add 1. We'll be left with 4 cosine squared equals positive 1. If I divide by 4, I'm going to get cosine squared of x equals 1 over 4. And then I can square root both sides. So the square root of cosine squared is just cosine of x. Right? Remember, when we square root, we want to make sure that we have both the positive and negative versions of the answer, so plus or minus 1/2. Right? So we want all the spots in our table now, our chart, where cosine equals 1/2, which will tell us that those spots are x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Right? It says it only wants the answers between 0 and 2 pi. We're only taking the answers from the chart, and we're not adding the pi n factor to it. Yeah. Moving on to question 6. We want to be able to factor this expression. Part A only asks us to factor it, which means we want to put it in a form that looks kind of like this. Two things being multiplied together. If you notice in this, it's kind of like a quadratic because it's got a sign squared and then a sign to the first power and then a number at the end. So we can factor it just like a quadratic, right? We want two numbers that multiply to positive 1, right? So that's, the only way to do that is either negative 1s or positive 1s. And since our middle term is a positive, they have to be positive 1s, plus 1 and plus 1. Right? And the only way to get 2 signs squared is to have a 2 sign and a 1 sign. So you can use whatever factoring method you like for these, as long as you can get it into this factored form. Right? So for part B, we're going to use our answer from part A to finish solving this equation for it equals 0. We can use our zero product property to split this into 2 separate problems. So 2 sine of x plus 1 equals 0, or alternatively, sine of x plus 1 equals 0. Right? I'm going to pause the video here so you can try solving these two on your own to get the sets of answers that we are looking for. Alright, so I have the answers for part B highlighted on here. There were 3 of them, so make sure you have all 3. Sometimes there will be 4, or sometimes there will also only be 2, or even as low as 1 and 0, depending on how many things are in the table. But part C asks us to use that answer from part B and give the general solution. So what that means is we're going to give all the solutions we found in part B, so 7 pi over 6, 11 pi over 6, and 3 pi over 2, right? And keep in mind the period of cosine and sine is going to be 2 pi, right? So we can add 2 pi to these answers and still have new solutions, right? And we can add 2 pi as many times as we want, and that's what this n is going to stand for. N is the number of circles we're adding to our solution. So this means the general solution, this is all infinity possible answers, because sine, cosine, tangent are all periodic, you will have an infinite amount of answers. Right? And then moving on to the last one, this one asks you to plug the equations into Desmos and give solutions between 0 and 2 pi. And so how you do that is you take each half of the equation, so y equals 1 plus sine of x over cosine of x plus cosine of x over 1 plus sine of x. It's one equation in Desmos. The other equation is going to be y equals 4, the right half, right? Put those into Desmos and see where they intersect between 0 and 2 pi. So I have that on Desmos here. So you can see I have the two equations plugged in on the top left here. I also do a vertical line for 2 pi to show us between what 2 points we're looking at. So we're looking for all the points where the red and the blue graphs intersect between 0 and 2 pi. So the black line and the green vertical line. Right, so there's 2 of them. So our answers are pi over 3 and 5 pi over 3. And that's how we find those. So we're going to get x equals pi over 3 and 5 pi over 3. Right? That's it for this video. Feel free to ask questions in class or before the test.